All right, we're going to do a couple examples here of some parabolas. All right, so we're going to talk about just, how do you work these through with parabolas? The first one we have here is a parabola, and both of these are saying, okay, graph the equation, find the coordinates of the vertex, the focus, the equation of the directrix, and the axis of symmetry. So the first thing I would do with this, it's already in my standard form, so I'm okay there. But I'd probably come off to the side and say I know that 4p equals 12. And therefore, because of that, p must equal 3. So having what in your head what p equals really does help to start. The vertex is our h and our k. Here, my h would be 0 because this is like x plus 0 squared, and my k would be a positive 1. So I got the positive 1 from here. The focus, this one is going to go kind of, I have in my head it's going to go open up, all right? So my focus is going to be above my vertex. So the focus is going to affect my y, and it's going to be 3 units above where this y value would be. So 3 above a 1 would be 4. The equation of the directrix would be below this. And again, it's going to be on that y that it affects. So 3 below the 1 would be negative 2. So the equation of the directrix here would be y equals negative 2. My axis of symmetry was going to be, it's going to be really my x-axis, my x equals 0 axis. So that would be my axis of symmetry. So then my last step here is just to graph this. So say to yourself, okay, how do I graph this all? I'm sorry, I make my graphs a little bit bigger here. All right, there, that's better for me. All right, so I'd start with the vertex, 0, 1. Here's my vertex. From there, my focus is 3 units away, if you remember, 1, 2, 3, and that was at 0, 4. My directrix was 3 units away, and the directrix is that straight line. So there's my directrix at y equal negative 2. We can draw in our axis of symmetry, and we kind of have this little axis of symmetry where it's going to be the same on the right and the left of that line. And then it becomes, how do we do our curve? We kind of know it's going to curve like this, but how do we do our curve? And if you remember, what you do is you start at your focus and you go 2p units to the right or to the left of your focus. So it's going to be 1, 2, 3, 4, 5, 6 here. And so here is going to be my focus here, or excuse me, one of the points here, and I'm going to go 1, 2, 3, 4, 5, 6. And so here is going to be a point, and so it kind of shows me kind of how my parabola is going to curve up. So there is my parabola. Let's look at another one here. Let's look at problem number 21. Now, problem number 21 is a lot more involved than problem number 6 was. Because in problem number 21, we first have to go through all the steps that it would take to get this into standard form. So I'm going to kind of give me some space here to do that, to get it into standard form, and then I can worry about how we're going to graph it. So I'm going to start with x is the value that's squared. So I'm going to bring my x terms, all of my x terms, and I'm kind of going to gather them together. And if I have a y term or a constant, I'm going to send that to the other side of the equal sign by doing the opposite thing. So technically what I'm doing here is I'm adding 12y to both sides, and so this would become a positive 12y. I'm subtracting 20 from both sides. So on the other side of the equal sign, it becomes a negative 20. So now what I need to do, before I can do completing the square, I have to factor out this 2. So I'm going to factor out the 2, and I'd have left x squared minus 8x, and I'm going to leave a space. I'm not going to do anything yet with factoring over on this side. It's really about completing the square on my left side of my equation. So now I want to complete the square. I take half of this negative 8 is negative 4. So I'm going to add 16 to both sides. Adding 16 to both sides. And now what I have here is I have 2 times x minus 4 quantity squared. Over here I have 12y minus, what is my minus negative 20 and positive 16. Oh, you know what? I made a mistake, and it's a very common mistake. With my plus 16, I forgot that this 16 was being impacted by that 2. So I'm not really just adding 16. I'm adding here 2 times 16. I apologize for that mistake of mine. So really, this is like a 32 here, and when I subtract the 20, I get plus 12. So now on the left side, I'm going to factor out my leading coefficient. I'm going to factor out my 12, and so I have y plus 1 here. And the only thing that's in the way is this 2 that's out in front. And so what I need to do here is I need to divide both sides, by that 2. And so what I have left here is I have x minus 4 quantity squared equals 6 times y plus 1. All right, that could be graphed. We could graph that. All right, so what we're looking for right here. First of all, we're looking for our vertex. Our vertex would be the value 4 comma negative 1. So I got my 4 from here and I got my negative 1 from there. I want to come off to the side or somewhere. I'm going to come over here kind of up in the corner and I'm going to say, well, 4p would have to equal 6, which means p would have to equal 6 over 4, which is really 3 over 2, which is really, you know what, I bet it'd be easier if I show that as a decimal. It's really 1.5. So the focus, now in this one, I know we have an x squared. So when we have an x squared, it's going to open like this, okay? So my focus is going to be above that. So my focus is going to be at 4 comma, instead of at 4, 1, 2, 3, 4, negative 1, we're going to be 1.5 above that. So we're going to add 1.5 to that, and it's at 0.5. Okay, so here's 1.5. We're about here for my focus. That's a little high, but that's okay. Here, I can move it down just a touch maybe. There we go. And then the equation of the directrix is below that. You go 1.5 units below that. And so 1.5 units below that is this point right here, and it's this line. So it's the line 2.5. So it's our y equals negative 2.5. So that's where our line was. We were here, and then we went 1, 2, or 1.5 down below it, sorry. So we're there at 2.5. Then the axis of symmetry is an x equal line, and it matches what is our x here. Our x is equal to 4, okay? So our axis of symmetry is this little line right here. So I know it's going to go up like a smile, all right? I know we're going to start here at our vertex. And the best way to decide how to curve it is you look at your focus, and you go to the right and to the left by 2p. 2p would be 3. So 1, 2, 3. We have one value here, 1, 2, 3, one value here, and it can show me how my parabola is going to curve up. So the last thing we have is just our assignment. Our assignment here, I wanted everyone to do, and what I did is I said, okay, I want you to do graph paper, and in the end, I only had students graph the evens. Okay, so if you're in my traditional class, you just had to graph the evens. And I think I even cut a few of these because it kind of turned out to be a lot. Like this one, I'm pretty sure I cut, and I cut a few. If you are in my hybrid class, so if you're in the hybrid class and you're watching these videos, the problems that I want you to work with, I'm trying to find some good ones. I'm going to have you do 14, 16. I usually have you do 4 problems. I'm going to try to find another one. You know, I'll do like 18. And I'm going to pick one more. I'm going to pick 15. So 14, 15, 16, 18. I do want you to graph all 4 of those, but those are your only 4 problems if you are in my hybrid class. Good luck.